Hello everyone, this is Harry Gill. We will continue looking into the terminal operation of the Java streams. In the last few videos, we have seen all these terminal operations, and in this video, we will look into the collect terminal operation. The collect terminal operation comes in two flavors. The very first flavor takes three arguments, and they are supplier, accumulator, and a combiner. You might notice that the signature of this flavor of collect looks very similar to the one of the flavor of the reduce method, which was the third flavor. In fact, collect is a special type of reduce, and you will notice that when we see how collect works. The second flavor of collect has only one argument, and that is of the collector type. And we will look into this as well. And like before, we will be answering these three questions for the collect method. I have already created a skeleton class with the main method, and within the main method I'm going to create a stream of strings. The requirement that we are going to fulfill in this example is that we would like to concatenate all the strings that are present in the stream. Let me write down the collect method, and then I will go in detail on its functioning. The very first argument of the collect is a supplier, and this supplier should supply a mutable object. A mutable object is an object that we can mutate, and the immutable objects are that we cannot mutate. For example, a string is immutable. A string builder is a mutable object. Mutable versus immutable is a different concept altogether, but for now, just note that string builder is a mutable object, and we do need to give a supplier of a mutable object as the first argument. The second argument is a by consumer. By consumer means it takes two inputs but doesn't give any output back. The type of the very first input should be same type that is produced by a supplier, which in our case is string builder. The second argument of the by consumer should be of the type of elements of the stream, which is string in our case. And in the body, the way we append a string into string builder is using the append method. The reason supplier in the first argument needs to provide a mutable object is because in the second argument we are changing that mutable object. If the supplier do not provide a mutable object, let's say it provides an immutable object, then in the consumer we can't change that in the body. And since by consumer doesn't return back anything, so there is no way for us to store the result of whatever we do in the body of that second argument. The third argument is a by consumer again. The only difference is that both of the types of this by consumer needs to be of the same type as of the object that is provided by the supplier. So in our case, that is string builder. And in the body of the third argument, we are appending the second string builder into the first string builder. Now let's see, how does collect work? Just like we did in the third flavor of reduce, for now, just forget about the third argument. We will come back to that one later. So what happens is, when the elements of the stream are being produced, the very first thing it will do is to get the mutable object using the supplier that we provided. And then it is going to pass in that mutable object as the first argument of the by consumer, and it will pass the first element, which is W in our case, as a second argument into the by consumer. We go into the body, we do string builder dot append W, and now we get a W. Now when the second element, O in our case, is produced, now since we already have the string builder, we wouldn't be getting a new one. So that same string builder that we produced in the previous step is being passed as a first argument of the by consumer, and the value of S will be O. And when the body runs, now we already have a string builder with the value W, and now O is appended to it. So now we have W and O in the string builder, and so on. All the four elements are created and they get appended one after the other. Once all the elements of the stream is produced, the string builder, which kept collecting the elements, it is returned by the collect method, which we will store into another variable and use it later. Now you see, just like the third flavor of the reduce, the third argument in the collect does not come into play if the stream is not parallel. Now when the stream is parallel, it is possible that the accumulation is being done by, let's say, two threads. So one thread will produce a string builder that will have the value of W and O. The second thread will have a string builder whose value would have been appended as L and F. Since they are parallel, now we need a combiner. We need to combine these two string builders. And now the way the results of these two threads are combined are by using the third argument, which is the combiner. So in effect, the combiner do not come into play if our stream is not parallel. Now as you see, if you know one of the functioning of either third flavor of the reduce or this flavor of the collect, you know how the other one will work. The main difference between the reduce that we have seen and this version of collect is that in reduce, we give an initial value and then the accumulation happens using a by function. But in collect, we give a supplier that supplies a mutable object and then the accumulation happen using the by consumer. And as you know, these lambda functions can be converted into method references. The reason I had used lambda is because it's easy to explain or understand how the logic works internally, but the concise way to write the same statement is using the method reference. As mentioned before, this collect will return the string builder. So I'm going to store it into the variable of the type string builder, and then I'm going to print the string builder. And now I will save and run the program. And as expected, you would see that all the elements of the stream are concatenated. Now to look at the next version of the collect, I'm going to comment these two lines. In the previous example, we have given our own instruction on how to do collect. For example, we gave a mutable object and we also told on how to put the stuff into that mutable object. In our case, we use the append method. However, Java creators knew that there would be some common use cases on how people will be collecting the objects. For example, it's a very common use case to actually collect a stream of data as a list. So to cater these kind of common use cases, the Java creators have created a second version of collect which takes a type of collector interface. Not only that, they have also created a static class called collectors, and this collectors class has a various utility methods which we can use. Now let's say the string stream that we have, we want to collect the elements of this stream as a list. So for that, I would use the second flavor of the collect. And the way I would do the collection is as following. So as you notice here, I'm using the collectors class to list, and this will give me a list of all the elements of the stream. Now, if I have to do this exact same thing using the longer version of the collect, then I would have created an array list, and in the accumulator, I would have added those elements into that list. Eventually, the collect method would have returned back the array list. But I don't need to write so big of a logic. I already have these utility methods. So since I'm grabbing this as a list, so I'm going to store the results into a list type and then print the list. And I'm going to save and run the program. And there you go. We have a list of all the elements of the string stream. So you didn't want a list, you want a set. So all you need to do is use the toSet method on the collectors. And I'm going to save and run the program, and we get a set. The reason the values of set are not ordered is, as you would know, that set is an unordered collection. Now let's say you want to collect a ordered set. So to get the ordered set, we will have to create a tree set. And if you look into the collectors class, there is no method called toTreeSet. So for that, Instead, we have a generic class which says toCollection, and in the toCollection we can provide the supplier of the type of collection we want. So in our case we want a tree set, so I'm going to provide a supplier of a tree set. And now I will run the program, and as you see, now we did get a set back, but now the set is also ordered. For the completeness, let's see how collect works for the infinite stream. So I have already created a small code. In here I'm creating a infinite stream of strings, and in my case it's just an empty string, and I am trying to collect it. Again, I'm using the string builder, and it's the exact same statement that we have already seen. And finally, print the string builder. And now I'm going to run the program. And as you see, we are not printing anything. The program is still running. So the infinite stream is keep on producing the infinite empty string. The collect method is keep on appending that empty string into the string builder. So it's waiting for the stream to end before it returns. So in short, the collect method do not terminate the infinite stream. And now let's jump back into the slides and answer these questions. The return type. The return type of the collect method, it varies. It really depends what your requirement is. Is it a reduction? Yes, collect is a reduction, and the reason is because we are going through all the elements of the stream and then producing the one output. So in our examples, we have given one output, which was string builder or the list in the second case, but it's still one object. So it is a reduction. What happens for the infinite stream? As we have seen in the program, the collect method do not terminate the infinite stream. That is all I wanted to discuss in this video. Now we have completed all the terminal operation. Starting next video, we will look into the intermediate operations of the stream. If you liked the video, please hit the like button. If you have any suggestion on the improvement, please let me know via comments. Until next time, bye-bye.